Okay. So we were talking about how there are these directories in some systems. It depends on the system. I mean, you don't have to remember this, but if you remember the basic idea. In this etc rc2 would be all the programs that we want to run when we're in run level 2. That's what the 2 stands for. And then everything starts with a K, means you kill that program. You kill this daemon, the DNS mask. I don't know what that is exactly. Something to do with DNS. You'll kill him. And this is the order. The numbers are the order in which you do it. And the S is the ones you start. Also the order in numerical order. So those would be the systems that you would, the background processes that you would start up and bring down in each run system. So there'll be RC1, RC2, RC3, etc. Yeah, so I started talking about this last time, that init tab has been replaced on most Linux distributions, and they use something called systemd, which is a binary program. In other words, what this is like very manual. I can just stick in whatever I want in here, and then that'll be run. Everything is very configurable. If I want something to be run in this level, I just add it here. And if I want, put it with an S. And if I want to stop something, I just add it here. Everything is like, but of course, it's a little bit dangerous because, I could put the wrong things in and I could delete something that was important. So systemd is actually designed to give you a little bit like limit the way you behave, or you interact with pre-written, with a program that has its own, it's not text files, it's binary files. You use the program called that comes with systemd to add and remove programs. So for example, let's see, let me just read this. Systemd, package of programs used for just about all process control. Processes have a service declaration file, which defines the conditions under which the process is started and stopped. For example, here you can define dependencies. In other words, start this process only after this other process has finished, has succeeded in starting. A service declaration file is not a bash script. And it's not a text file that I can just write. It is a special, it is interpreted by the system binaries. In other words, it's got its own special format that you write, and then it's not a bash script that just runs the script, it does something that you can understand. You just say certain informations in a certain format, and the binaries read it. The binaries that come with systemd. Logging in systemd is not done by a text-to-text log system, but also in a binary form in a systemd log, which you can access through another systemd utility. In other words, there's no text files. Everything is through utilities that come with systemd. And that system is called journal control, journal CTL. That is how you check the logs. Systemd provides a declarative way of defining startup and other process dependencies. That is good. In other words, I can see when I read the file what's dependent on what. I don't have to just notice the order, like in the RC file, you have to have in RC directory, you had like the order of the numerical order told me which came before what. But maybe it just happened to come before something. Did I know it's dependent on it? No, I just know that it happened before. But here I can actually declare this is dependent on that. But the actual execution of the systemd binaries and the logs produced are more opaque. In other words, I can't read them directly than under the previous system, which we just described, which tends to make system admins a bit nervous. And as in general, as a system admin, you want to see all the text files, how everything is run. But it is a standard part of most Linux distributions nowadays. Okay, so here's this function called system control. So you can type, if you have systemd running on your system, which Avraham does, he can type system control space list units to show all the services that we could run. So you see what I mean? These are, we're using a program as opposed to just like looking at a file. System control status SSH that service. It will show the status of SSH. Is it active? Is it enabled? Meaning it will be a run at system startup. In other words, it can be disabled or enabled. Enabled means I do want you to run it when your system starts up. Disabled means don't run it when the system starts up. It doesn't mean you can't start it later, but it just will be disabled at system startup. It won't come up automatically. So I can do, everything is with a dot service at the end of it. So system control status SSH dot service. It'll show me whether SSH service is enabled, disabled, or active. And I could also disable it. I can say system disable SSH service. You need to be sudo, obviously. Now what I'm saying is change the binary files so that on login, on logup, it won't come up automatically. You see what I mean? So you see, I'm not changing the file directly by editing the file with VI or Pico or Emacs. I'm using a binary a command in a binary program to tell it what I want. Disable SSH service. Enable SSH. You can assume the service extension is assumed. You can do stop, which is just to stop it from running, but not to disable it on the next log up. In the next startup, it will come up again. And then I can start it again. So you see, system control is how I would now deal with all the services that I want. I can also do restart. If you change the configuration file, this would be useful. In other words, you have your SSH, everyone knows is like how to communicate between two different computers. So two computers can talk via the internet. Or I can log into another computer using SSH. So restart, if I change the configuration files and I want to restart SSH, I can do this. I can do just is enabled is a question. As I could have done status, and it shows me its status. But I can also just ask, is it enabled? SSH reports whether the service is enabled. Enabled, of course, doesn't mean whether it's running now, but whether it will run when I restart the machine. System -- failed. Show what services failed to start up on startup. When I started the computer, what failed to come up. So you see the methodology. The methodology is I run a program and I inquire from that program what's going on, because I can't look at the files directly. And that's what I meant by saying it's opaque. System control reboot. Well, that just reboots the whole computer. Power off, shuts off the computer. So you see now, we used to say, tell init, 0 or something. Tell init 6 to shut down. What level I want to go to. Now we're gonna, now I can do system control reboot or system control power off. System control list dependencies SSH daemon service. Show the hierarchical mapping of dependencies for this service. That is, what does the SSH daemon require? Then I have system control edit SSH D service to edit those dependencies of specifically SSH. So you see, I don't open a file. I run an edit command. So when I run edit commands, then I can type things. Now, how do you define dependencies in systemd? I mean, you probably won't have to do this, because when you get a description, when you get your Linux installed on your computer, it's going to have all of this set up already. But I'm showing you what you could do. So, for example, dependencies. That was one of the main things we wanted to be able to show. Because in the other system, I just put something numerically smaller than something else, so it would run first. But I didn't know if it was actually dependent on it, or if I just happened to choose to make this one before that one. So if unit 1 has wants equals unit 2 as a dependency, So that means unit 1 essentially wants unit 2. It depends on unit 2. When unit 1 is run, unit 2 will also be run. So as if unit 1 has defined, if some service unit, like let's say a service, if some service has a wants unit 2, then that means when I run 1, it'll automatically run 2. But in such a case, this means whether unit 2 starts successfully or does not successfully, but whether unit 2 starts successfully does not affect unit 2 running successfully. In other words, it will run, it will not stop running unit 1. In other words, I'm not saying don't let unit 1 run unless unit 2 succeeds. I'm just saying when you start one, start the other. I'm not saying don't let unit 1 turn it off if I'm not saying turn it off if unit 2 fails. But when unit 2 requires equals unit 2, then again, both units will run. But if unit 2 does not succeed, unit 1, it will become deactivated. In other words, don't let it run unless you have this other thing running. This happens regardless of whether the processes of unit 1 would otherwise have worked fine. In other words, once I define it that it requires unit 2, then it actually requires it. It will. In other words, even though theoretically it may not require it, it may not actually really need it, but if I defined it that it needs it, then the minute that unit 2 fails, unit 1 will be turned off. If unit 1 has a directive, it also could have another directive, before equals unit 2. Then if both units are run, unit run will be executed fully before unit 2 starts. In other words, unit 1 is before unit 2. So I have to execute unit 1, and then I can execute unit 2. If unit 1 has the after, then if both of them are run together, in other words, we're not, unless we could combine them, we could say it also wants. We could say unit 1 wants unit 2, and it's after unit 2. So then if I try to run 1, it will wait, it won't run until 2 gets run, and 2 finishes, and then 1 will run. There's I can combine them. But all that after means is that if they're both run, for whatever reason they're both run, as it could be if I just run unit 1, then unit 2 may not run. But if I just by writing after. But if they're both run, for example, I run them manually, or because I have a wants, then unit 2 will be executed fully before unit 1 starts. So here's how it's going to look. So you're going to see, like, for example, when you edit, remember how we did this? We said edit on a particular service, edit SSHD service. So now when we're editing, we're only editing SSHD. So we don't have to write what thing we're editing because we know. So we just write wants. What does SSHD want? It wants SSHD key generator.service. In other words, you should also run the key generator, because if I don't have a key generator, by the way, this goes back to the other class, you can't do SSH if you don't have a key generator. So you want to run that. But actually wants just means that I'll still let the program run if it fails, because it's not like it doesn't need it all the time. It's not critically dependent on it. It just needs to use that. After and it. So what does after mean? In other words, if I try to run SSH first, I'm gonna run this command, network.target SSH generator service. The ordering directive after ensures that the SSH server will not run until after the host key generation unit. So I have a host key, and after the network is up. The network target unit ensures that various units bring up the network. right? The network target unit that says that essentially starts up the network. Dependencies like wants and requires are often used together with after to preserve proper dependencies and order together. In other words, I also want the order, and I also want the requirement that if one starts, the other starts. Usually I put them together. All right, that's the whole system of system control. That's how you control system D. See, now this stuff is actually how to run how a Unix system works. So this is really relevant to the course, but it's not traditionally taught in the course because we focus more on the programming aspects. And this kind of stuff changes because 10 years ago they didn't use system D. Okay, journal control. In system D, the logs are not text files, as we said. They are binary files. So must just the command journal to see them. I must the typo. So you must use. So you must use the command journal control to see them. So for example, if you just write journal control, I don't know, Abraham, maybe you want to try that. Type journal control just to show the logs. Journal control -B show just the boot logs. That is what logs happened when the machine booted up, not all the logs. Journal control -U, there's probably no space there, SH. Show just the logs related to SSH. And as U is unit.
Hello?
Yeah, just a second.
Oh, okay.
Yeah,
I thought you froze.
Yeah, sorry, I'm just doing something. Just remembered something. Okay, so we finished with that. Okay, now that's enough of system D. Just a second. Just a second. Okay, there are many demons. For example, Cron Demon. Do we remember what demons are? Demons are detached programs, are programs that are running in the background. In other words, when you do PS, AUX on your system, and you see all the processes that are running, you'll see loads and loads of processes. And so in order for the computer to run and do all the things it's doing all the time, it has like lots of processes running. Most of them aren't doing much most of the time, but in order to maintain your internet connection, there's lots of things going on. So those are all called demons, and they're called demons because like they're invisible. They're like ghosts. They're like, I think that's why they're called demons. They're like things that are working in the background, but they're invisible and they're like doing stuff. And there are lots and lots of these things, and a system needs to control them. So there are what we're going to talk about actually, I think, is system is a configuration files. But let's see. I forget exactly what I wanted to say here. Demon. There are many demons. For example, Cron Demon is a demon. So demons to execute. This is a special demon to execute scheduled commands. So now I'm just talking about an example of one daemon that you have at your that you can use on your system that could be useful for you. It's kind of like a calendar. We'll see. Daemons to execute scheduled commands. In other words, I can command, for example, I can make a daemon that on my server, on my wife's birthday, it's going to send an email to her from me saying happy birthday, right? And I didn't actually have to write that. And she'll say, oh, thank you for writing that email. But I'll have like a script that writes an email and sends it to her, and I'll activate it at a certain date and a certain time every year. Right? That's like a fantasy of the system admin person to, you could, after you're dead, you could still be sending the emails, So how does that work? So cron searches, so there's a daemon called cron, and it searches a place var spool cron for a cron table, for cron table files. There's many files there in this var spool cron, which are named after accounts in etc password. In other words, etc password is all the users on the system, and in the cron directory there'll be a cron table for each user, because each user can create his own cron jobs, they're called. The found cron tabs are loaded into memory. So all the things that are here are loaded into memory, and they're actually in memory. Cron will search. So, okay, and then cron will obviously look at that to decide what to do. Cron also searches for etc anacron table and the files in the etc cron.d directory, which are in a different format. Well, there's different types of files to save this information. Cron examines all stored cron tabs, checking each command to see if it should be run in the current minute. In other words, in this minute, it has to go, it's sort of like polling, goes through all the things listed in the cron table, and if this is the minute to run them, according to the cron table, then it'll run that command. So every minute, it's going to check all the things that need to be run this minute. Sounds kind of inefficient if you have like millions of users on your computer, but because you run checking every single, that request to send the email to my wife is going to be checked every minute forever. If this is the minute, it's like a very dumb worker. Is this the minute? Is this? It doesn't know how to wait. You could, of course, set it up to wait with an alarm clock. But so, what is the format of a cron table? This is actually a pretty useful thing to know, to understand. So you have the field. Here's the field, the meaning, and the loud. I'm going to jump to an example, but because it's easier to understand. Here, let's look at this example. What does this mean? This means every 5 minutes, at minute 5, 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and 60 would be 0. At every 5 minutes, run the command devdaily.com bin do update.ssh. So every 5 minutes, we're updating, something at dev daily. I don't know what it is. We're updating something. This is, by the way, if you're in my other class, this is what we talked about. It's called like a microservice. Some microservice at this website that does do updates and whatever. I'm running this command by me, but it is obviously going to connect to some server, and we get some information from it. But whatever it is doesn't matter. What matters is that it's running every 5 minutes. How do I know? Because I wrote here every 5 minutes. And it's in the first field. Notice in the star, star, star. So the maximum I could have is 5 stars. If I have 4 stars, then that means like this. These 5 minutes, when? Every day? Every year? What does this mean? So it's like this. Do it at time 0, at time 5, when? Every hour of every day, of every month, of every year. So that means every 5 minutes. That's what I wrote over here. So look, day of the week, actually. So we have minute, is that's the first field is the minute. Second field is the hour. So it can be from 0 to 24, 23. Day of the month, 1 to 31. Month, which month to do it in? As I can say, only do it on the 14th of February. And only do it if I would have 4th of February and only on a Sunday. So that means only happen when the 14th of February is a Sunday. Usually I wouldn't combine the dates and the week. Usually I would either say every hour, every minute on, this hour, this minute on Sunday night, at 12, at hours 00, no, at hour 59, at minute 59, at hour 23, there'd be 11:59 right before midnight, a minute before midnight on Sunday. So it'd be Sunday night. So I'd write here 7 for Sunday. What does it mean? 0 or 7 is Sunday. Because there's actually 8 numbers here. It's like the Beatles song, 8 days a week. There's actually 8 numbers here now, right? Should be 1 to 7. So actually 7 is also Sunday and also 0. So if you're Jewish, you say 0 is Sunday. And then the last day of the week will be 6. And you'd never use 7. If you're Christian, you can write 1 and then 7 will be Sunday. The point is, I never thought about that before. The point is, you can set up things. So here's some examples. So for example, if I do all stars, it means run this command every minute, every hour, every day, every month, every week, every day of the week. This command means this command will run at 12:05, 1:05, etc. In other words, at the 5-hour point, at the 5-minute point of every hour of every day. And notice I can do a command as complicated as I want. Get, wget with parameters and the website I want to go to. Here, run this backup script. Here, this I want to run at 4:30 a.m. So I write hour 4, minute 30, and it's going to run every day. This is also going to run every hour. I don't have an example actually of like running once a week. Here, let's change this. This command will run at here. Oh, we should. Here, let's change this to on Sunday. So what do I write? Somebody help me? By the way, what is 4:30 on Sunday? That's early in the morning on Sunday. So that's a good time to do it. So we'd write here 0, for example. I could also write 7. People with me? I'm having.
Yeah, I'm just.
You just what? You got this? You understand why this is 4:30 a.m. on Sunday?
No, I get the concepts. The problem when you said, what should I write? I'm just bad with commands. Like I have to drill and like.
Well, yeah, I've done this. I've been doing this for 20 years. And you.
So when you say like, what do you write? I have to like actually look it up. I don't know.
Yeah, it's hard to remember. Yeah, fine. Okay. So here, day of the week, 0. So 0 or 7 is Sunday. So that's what I did. Okay, fine. No problem. Okay. That's enough of cron tab. That's a very useful thing because everybody has his own cron tab. I think there's special commands for cron edit. I think you can do cron tab -E, as I recall. I don't know why I didn't write that here. Avraham, you want to check that for me? cron tab minus E allows you to edit the cron table. Instead of manually editing the file, you can also manually edit the file, but you can also do cron tab minus E. But which is different again from system D's style. That's the way Unix people like to work. There's an editable file. Here, what do I write? Common file systems. Just another piece of information here. Common file systems in use in the Linux world. So this is the maximum file size. This is TIB is hebibyte. What is hebibyte? I wrote this and now I'm confused by it. Whatever. So a TIB is a tebibyte. And a tebibyte is 1,024 gigabytes. A gigabyte is 1,004 megabytes. 1,024. So a tebibyte is 1,004 gigabytes. A PIB is a pebibyte, is 1,024 tebibytes. And an EIB, an XB is 10,024 pebibytes. So it keeps getting bigger. So here are different systems. So FAT63, file allocation table 16, means a 16-bit file allocation table that gives you a maximum of maximum partition size of 2 gigabytes. You can partition a disk into sections, and each, if you have a bigger disk, let's say you have a 16 gigabyte disk, you would have to make 8 sections because you can't have a single partition larger than 2 gigabytes. Nowadays we use here, NTFS is very common in Windows, but you can also use it for Windows compatibility. It is installed by default in Ubuntu. Now, this type of file system allows you to also work on Windows. See, some of these don't. Legacy is a code word for no longer used, but it exists just to deal with what used to be in the past. But NTFS is pretty common, and this allows you a partition of what we would call terabytes. I would call it a terabyte. Here it says tebibyte. So this allows you only 256 terabytes. If you want a single disk of 512 terabytes, you'd have to divide into 2 partitions on if you have an NTFS.
Nachum.
Yeah.
A terabyte is actually less than a tebibyte. It's 1,000 gigabytes, not and the tebibyte is 1,024 gigabytes. They're different units, where each time one scales by 1,024, the other one scales by 1,000. So as you get bigger and bigger, the difference between them gets bigger and bigger as well.
Okay, thank you. So a terabyte is really? Are you sure about that? Is a gigabyte also? I thought a megabyte.
No, it was explained. But originally, megabyte, gigabyte, and everything meant 1,024. But then common people just started calling it 1,000. So then everything by 1,000, they just called mega, gigabyte, megabyte, gigabyte. And then for the tech people, they just made a new word called tebibyte, and that was powers of 2. So there's just.
Thank you, because that explains. I'm so old that I remember when there was only one thing.
Right, yeah, but like when they sell a phone and it says 64 gigabyte, legally that means 1,000 megabytes. Right. I think.
And that's why when you look on it, if you buy a computer, by the way, with like, I don't know, 64 gigabytes of memory, and then you look at your memory, it'll say 62 gigabytes of memory or something like that. Because
of the OS.
No.
No, yeah, it's actually because they have less. Because
isn't 60. That's exactly the point. That's exactly the point, because when they're selling you 64 gigabytes, they're selling you 64 million bytes. But that's not what 64 gigabytes is. 64 gigabytes is 2 to the 9th 64 times 2 to the 9th bytes. Notice it's a different number. So when you convert, when you give me 64 million bytes or billion bytes, and you put it on, and the computer looks at it, the computer says this is not 64 gigabytes, because it isn't. It's 64,000 bytes, but it's not 64 gigabytes. So that's why I write 62. That's why I specifically said memory, because memory is always the same. Memory doesn't get used up. When you ask how much memory do I have, that's how much memory you have. I'm not talking about free memory space. Also on a hard drive, if you buy a 64 gigabyte hard drive, it's going to show you, forget the used and unused, it's going to show you the full size of it is less than 64 gigabytes. That's because of this advertisers lying to you or selling you a gigabyte as though a gigabyte is.
No, they're not. They're not lying. It's just that people who aren't computer scientists don't understand the power of toothing.
I understand what you're saying. You're saying they're not. I would. Well, in the old days, we said they were lying. Maybe now we've conformed language to their use, and now we've invented a new word to describe what we mean.
Yeah, and ordinary people aren't going into their hardware to see the actual.
Okay, whatever.
I don't know.
Anyway, so that's what. So actually, you guys are telling me that either way it comes out, a gigabyte, a gigabyte is 1024 megabytes, but a gigabyte is different. It's a billion bytes. Okay. I don't care. But in any case, you see that there's different size of a single disk. Here you have the ext4 allows you 1 exabyte, which is quite large. Anyway, this table, you obviously don't have to memorize it, but you should just see that there are a lot of different types of file systems. And if you think there's only NTFS, so you should know there's other systems, there's other things. Even ext2 is written here as legacy. Here, standard Linux file system for many years, best choice for super standard installation. So ext3 is very standard. The ext4 is the modern iteration of ext3, best choice for new installations where super standard isn't so necessary. So I guess the debate would be between ext3 and 4 in general, if you're talking about Linux. But if you want Windows, you should use NTFS. That's why Ubuntu, see, Ubuntu is a version of Linux specifically designed for Windows users. And especially for like a dual boot, where you want to be able to boot in Windows or in Linux and have the same files, be able to view the files either way. So you have a dual boot with Ubuntu and Windows, you're going to definitely want to use NTFS. So that, because Windows has to use NTFS, Windows can't use ext3, as far as I know. I don't know. I don't think so. Okay. So now that you have that, we have something called the FS tab. Tells the system what disks to mount and where to mount them. So if you think about what we said here, we have a partition size. So technically, if I have a disk and I'm using ext2 or ext3, I can only have 32 terabytes. But if I have a disk that's larger than that, I'm going to have to make 2 partitions. So essentially, I have 2 disks. Also, I can have 1 disk where I can, even if I don't, I could make 32 disks on this disk, each one with 1 terabyte. It'd still be pretty big. So in other words, I could have lots of disks on it. In other words, from the operating system's perspective, once I make a partition on my disk, it's as though I have 2 disks. Now, as a partition means divide the disk up, even though it's 1 physical disk, view it as several disks. And that was originally done because of these limitations on FAT16 and FAT32 that were, well, FAT16 especially, that was quite small, 2 gigabytes. And if I want to have a disk that's bigger than that, I'd have to have multiple partitions. So, especially because of FAT16, they invented this idea of disk partitions. so that I can have each disk viewed as a separate, each part of the disk viewed as a separate disk. And now we're now want to talk about mounting those disks. Mounting a disk means connecting a physical hardware to a logical place in my file system. My file system is a hierarchy, a tree-like hierarchy of various places. I can go up and down in the directory structure. Now, pretty obviously, it doesn't have to be this way, but in a normal way of imagining it, you would say, well, the disk will be mounted at root, / the top of the file structure is / put the disk there, and then everything is in that disk is under that. But what if I all of a sudden want a second disk? Where am I going to put it? So I can't also put it, if I put it also at /, then it'll overwrite the other one. I won't see the other files. So I want to put it at some other place. So I can I can go down my tree to some random place and have some directory there called other disk or whatever I want to call it. And then mount that other disk to the location called other disk, to that directory. As I'll have my tree going down, left, right, right. And I come to a file, a directory. And in that directory, I'll mount my second disk. So that means as long as I'm on the file tree and I'm not in that location, I'll be on disk 1. And the minute I do CD and I get to that location, boom, I'm already on a different disk. It looks like, it's like here. It's similar to this. I'll show you on my Windows computer. Here, stop share. Share. Okay. Look here. I have this. I made this little link. Where is it? Here. Movies on D. So this is my C drive, right? Everything on my desktop is my C drive. But this, if I go into this folder, I'm all of a sudden on D, on data. See that? I'm not on C anymore. I'm on D. So I essentially mounted my D drive into my file structure underneath the directory called, desktop. If I go to desktop, I see underneath this something called, where is it? Movies on D. So that's essentially what a mount is. I'm connecting another disk to this directory structure. I don't have to go up to C and then across to D. I don't have to click on this. I can just click within my PC desktop and go to there. Okay, that's the idea I was trying to say about, that's what a mount, that's the concept of mounting. Okay, so view present. So the file system table tells fstab, tells the system what disk to mount and where to mount them. etc fstab is a list of file systems to be mounted at boot time. So when the system boots, it's going to mount various disks. If you want your file system partition mounted once your computer boots, you'll need to put the appropriate entries into fstab and into, so what is etc mtab, mount table, is a list of currently mounted file systems. Whatever is currently mounted. The command mount -a will mount all the disks in the fstab. So in other words, the command mount -a stands for all. It means mount everything that's supposed to be mounted. Because I could have unmounted things. So it means connect them. Connect those disks to those places that I defined in the fstab. Alternatively, you can manually mount the disk with the mount command. So for example, I could do mount -f nfs, the type, remember NFS, if you remember over here, NFS is NFS NTFS, I guess, is the same as NFS. And what am I mounting? I'm mounting the disk Pluto its export packages to the directory mount. Right? Mount point is here. Where to mount it to. This is the server, the name of the machine, and the directory. In other words, I actually don't have to mount a disk. I can also mount a directory of another machine. In other words, sorry, NFS is not NTFS. I forgot. NFS is network file system. That's just saying that I'm mounting this disk, but it's somewhere else. It's on another computer. This is kind of weird. On one server, I can mount a disk of another server as long as I'm running the network file system, network file service, which allows that. So I'm mounting a disk from Pluto, from server named Pluto, which is exporting in a place called export packages. So it's a special disk that it has ready to be mounted. Now here's a sample FS tab using kernel name descriptors. So the device, this is like the actual disk. Remember, everything is a file. So the disk is in device SDA1, device SDA2, dev SDA3. And I'm mounting it to, this is the mount point. This is going to mount to slash. This is not going to mount anywhere. It's just going to be swap. It's a special kind of disk. A swap disk is like for virtual memory. And this is going to mount to slash home. So if I go underneath slash anywhere other than home, I'll be on SDA1. But if I go to slash home, I'll be on a different disk. And this is the type. Remember, we learned ext4 is a type of a file system. exFAT, was that on our list? No. Interesting. exFAT is another type. We'll explain. So device is the block special device, the partition or remote file system to be mounted. That's over here. That's what I'd write, Pluto, colon, and then whatever place on Pluto. Or here, I didn't write Pluto because I'm not using NFS. I'm not using it. It's all local. Dir is the mount, where to mount it to. Type is the file system type that we explained. For example, will the file system support window files or only Unix? What is the maximum size file allowed? So that we saw that before. Options, the mount options. You can see the manual to see what example. No access time recording. Doesn't as you could tell it, for example, not to record last time it was accessed. For example, last time a file on it was accessed. Dump is checked by the dump utility. This field is usually set to 0, which is what I did here, which disables the check. Will core dump file be created or not? So by setting to 0, you won't create a core. If a program crashes, sometimes it'll put all of its memory into a file. And if you set this to 0, then it won't copy. It won't like put this record of its memory and registers into the directory. FSTK sets the order for file system checks at boot. Notice first I check the swap, then the root, and then the home. For the root device, it should be 1. For other participants, it should be 2. Or 0 to disable checking. So in other words, the swap disk, we don't need to check. What are we checking for? Checking for like bad clusters, bad blocks, things that are defective on the disk. It's not so relevant for a swap because there's nothing going to be there at boot. No information will be there. These ones will have some information there. And there are ways of correcting because of redundancy, damaged disk sectors. So So 0 means don't check. 1 means the first thing to check. And root obviously should be the first thing to check. You don't want to start mounting stuff if root is failing. Okay. So F disk minus L shows me all the partitions. In other words, there could be one disk, but many partitions. It shows me the partitions. I guess this is like the sector where it starts, the sector where it ends. Is this, yeah, so this ends here, and then this one starts a little bit later. Doesn't start right next to it. There's like a gap for some reason. And then this one and then this one ends here, but this one starts immediately after it. So you've got various information here. If you do F of disk that minus L, it shows you where on the disk these sectors, these partitions are actually located, how many blocks are in it, what its ID number is, and what type of, if it's NTFS, it says what type of system it is. Okay. Now we're getting to a little more, a thing you probably used a lot if you ever had an Ubuntu system, Sudo. Sudo is actually based on a different command called su, S-U, which means super user. And you used to actually be able, if you are the super user, you could change to any account. Sudo, su, you just write S-U, and then, Moshe. And now you are Moshe. You have access to all Moshe's files, and you are Moshe. But you can only do that if you're the super user, which means you had access anyway. But you'll not only get access to his files, you'll get all of his environment variables as though he logged in. So you'll actually be running as though you're him. And if you change one of his files, it'll look like he changed the file and not you as a super user. So that's SU. It also SU, if you're not the super user and you type SU, it'll ask you for the super user password, and then you'll become the super user and you'll have access to all the file system if you know the password. Now, Ubuntu says like this. Now, a certain way of working on Unix would be, maybe a lazy way would be to become a super user and just do everything as super user. I don't need to be, it's my computer. I can do whatever I want.
Is this superseded?
What?
You're saying sudo?
Say it again.
Let's say you're currently on a user that doesn't have permission to download stuff. Would sudo supersede that and stuff?
So, well, first, before I talk, actually, I should have added another slide here. Let me add another slide. I'm just thinking of this now as we're talking. Here. SU. Super user. So if you do something like SU Moshe, then now you are user Moshe. SU, now you are the super user. Now, SU will ask for a password if you are not the super user already. So in other words, if I do SU Moshe and I'm the super user, it won't ask me for password. If I do SU with nothing, it also will not ask me a password if I'm already the super user. But if I'm not the super user and I do SU Moshe, it will ask me for Moshe's password, which I don't know. If I do SU and I'm not super user, then it'll ask me for the super user password. And if I don't know it, I can't become super user. But if I do know it, then I become super user. A super user has access to all the files on the system. Can delete them, etc. Now in Ubuntu, what they do, now some systems, what they did is they automatically logged you in as super user. But what Ubuntu did is they said, like, nobody's super user, that you can't be, SU won't work, and there's no password. Now you have to create a password for the super user, right? So that you can become super user, so you can do stuff. But when you installed your system, it asks you for your own password. It never asks you for the super user password. So how are you going to become a super user? So what Ubuntu said is like this. Instead of giving everybody two accounts, two passwords, the super user password and the regular password, we'll just we'll use the sudo command, which already existed. What sudo does is allows you to execute, here, let's change this also. Execute commands as a different user, namely super user. Okay. So you can run a script as if you are a different user. If you don't specify a user name, you will run the script as root. There is a file called sudoers, which lists which users may run sudo as root. Examples: sudo -u yaz ls tilde yaz. To edit the I don't know what the ls, what does the ls tilde yaz mean? Not sure. Oh, this is an example of using it. Now I understand. I thought this was saying this is not an example. Example. There is a file. I didn't explain what the file looks like, but examples of using sudo. You already played on it. No. Yes, you did for a long time. No. Yes, you did. No. I gotta teach now. I can't talk to you. Did I know that? You did. I'm teaching now. I can't talk to you. You should go away. I did. You used it. I took it away from you in the middle. You used it for a long time on the couch. Okay. So examples of use of sudo. Sudo -u yaz. In other words, I want to do -u is the user. I want to do as user yaz. I want to do ls tilde yaz. Sudo -u yaz. I want to do the command ls tilde yaz, and I want to do it as user yaz. So I do sudo -u yaz ls yaz. So that's the whole command that I do. Or for example, to edit the index.html file as user www, I would do sudo -u user www, that's the name of the user, and then run the command vi on the file tilde in the directory www htdocs index.html. So I'm going to edit that file as www. Why would I want to do that? Because when I save it, I want to save it as being owned. I don't want to change the ownership of it. If I would edit it, even if I had access to it, if I would edit it, let's say I edit it as root. Now, all of a sudden, the ownership of it changes to root, and poor www can no longer edit it because it's owned by root now. So I don't want to edit it as root. I want to edit it as user www. That's sudo in its general use. Now, I should wait. To view the system logs only accessible to root and users in the admin group, do sudo -g group admin. I'm going to put myself in the group admin and then view, run the command view on this log. To shut down the machine, here's an example where I don't write anything. I don't write -u or g. And that means I become super user. So on your Ubuntu, you could do this. This is what Ubuntu expects you to do. Ubuntu expects you to, you can't become root by typing the root password. There is no password. But you can do the command as though you're root by just typing sudo shutdown to shut down your computer -r, which is reboot plus 15. And then the message that you want to send to all the people on the machine who are logged in is 15 seconds until reboot. So that would shut down your computer or reboot your computer. Actually, yeah, shutdown plus -r, -r means with a reboot. So notice here, I didn't specify user, so it assumes that I'm becoming root. But I'm only becoming root for the command. How would you actually become root on Ubuntu? Can anybody think of that? How would I actually become root on Ubuntu? In other words, not just for one command, but for always. In other words, for until I change it.
Repeat the question.
How could I? Here I was running the command shutdown as if I'm root by writing sudo, which means
you're using sudo.
Super user do. That's what sudo stands for. Super user do. Do this as though you're super user.
I don't know. Maybe you can change yourself to the super user.
What?
If you're already the super user.
I'm not the super user. I'm Nachum or Moshe.
Can you use sudo to change your user status?
Yes. Well, you saw that here. I did. Well, here I just did.
No, I'm saying to make Nachum a super user now.
So all I would do. So look, if I would write sudo -u yaz, and that's it, then I would be, or then I would be, oh, actually, no. If I would do sudo -u yaz, I don't know if it would understand me. But what if I did this? Here, this is the answer to my question. And then you'll understand the question. Sudo su. What does that do? I'm running the command su, which makes me the super user. But I'm not able to do that, but I'm going to run it with the sudo command. So now it's not going to ask me for a password because it thinks that I am root when I'm doing it. So now I'll actually become the super user. But this only works if I, Nachum, or whoever is logged in now, is listed in the file called sudoers. Here, let's see. Sudoers file example. Oh, it's sudoer, not sudoers. Sudoers. See, I wrote it sudoers. Why does it say sudoer? Here you see, for example, users, local hosts, no password required. But that's not what I want. I want an actual example. That's a theoretical example. All right, well, here, Joe. Joe may sudo only to operator. Joe, you can do I don't know what all means exactly. Sudo operator, that command he can do. Only that one command. Here, Jim may run anything on machines in the big lab net group. All. So you just write all. If you just write Jim all, that would mean he can do anything. Okay. All, whatever. So in other words, you can define exactly what permissions you want to give somebody or everybody. You can create all that would let everybody do that. To mount and unmount the CD-ROM, right? You want everybody to be able to put the CD into the drive and use the CD. Well, the only way that could work is if you mount the CD, and mounting is something only a super user can do. And I don't want to give everybody super user rights. So I say all people can mount the CD-ROM with no password. Okay. So that's pretty important, actually, that concept, because I use it all the time. Okay, no hang up. No hup is a command to ignore the hup or hang up signal. The hup signal is, by convention, the way a terminal warns dependent processes of a logout. Wait. Output that would normally go to the terminal goes to a file called nohup.out if it has not already been redirected. The command below starts the program ABCD in the background in such a way that the subsequent logout does not stop it. You see that? I'm in a shell, and I'm about to exit from the shell. It's going to exit from the computer. I'm going to go log out of the computer. When I log into a computer, it gives me a shell. If I do exit, it takes me out of the shell, no longer logged in. So the exit is going to mamish take me out. So normally, if I would be running a command like ABC in the background, it would end because I'm no longer there. I ran it. If I go away, then it goes away too. But if I write no hup, then it continues running even though I have left. So let's read that. To ignore the hup hang up signal. In other words, it used to be that I would connect to the computer by a phone. So when I logged out, this exit essentially is hanging up. It was like I put the receiver on the phone and hung up. So that's called a hang up. This exit is really like a hang up because I'm no longer connecting by the phone line. So, and normally there's a signal that happens of hup, and it's sent to all the processes that I created and kills them. Because why? Because my processes aren't going to keep running when I'm no longer there. But if I type no hup, then the hup, so the hup signal is by convention a way of terminate a terminal process warns dependent processes about a logout. So when I log out, the terminal will tell ABCD that I logged out. But what should he do? Well, if I type no hup, then he's not going to end. That's what no hup does. All right, I want to stop here for today. We're going to have a lab. Let's have a lab in 15 minutes, okay?
Okay. Okay.